Hey guys, this is Jim, K4YCD. You're watching FEP Labs Radio. Thanks for stopping by. This looks like a hot mess, but I have a plan. Now, what I am planning to do, let's talk about it. This is a collapsible milk crate. You let it go and pop the sides out and it's a milk crate. And it'll hold, I don't know, 50, 60 pounds, something like that. These can be had at Home Depot for, I don't know, $6, $8, not much. Milk crate. And then we have a 100 amp hour Chins battery, LifePo, deep cycle. See, it even says deep cycle on it, so you know this is serious battery. And then we have an inverter. Now I bought this off of Amazon. I bought the Chins off of Amazon. The battery retails currently for about $360, give or take 20 bucks on that. When I bought it, it was over 500. So LifePo batteries have gone down in cost a lot. This same battery is less than 400 now. This is a Bestech 2000 watt inverter. And I don't know if it was in the video, but I used this at Huntsville when T.O. and I were testing out the QRZ-1 FM handheld radio outside. So this is it has an on-off switch, gives us 3 plugs, 2000 watts continuous power, 4600 watts inrush certification, 6 50 amp fuses in here, and then our connections. Now, this is interesting, and I guess it's because of the wire size. I'm sure it's because of the wire size. You're supposed to hook up all 4 clamps at one time, so you can carry more current and fully load this thing. And then these are fastened on with binding posts. Now, for today's video, we're going to use the clamps, but I believe down the road I'm going to try and find, I'm probably going to buy some of the heavy duty big power pole connectors so I can have a quick disconnect sort of thing instead of fooling around with alligator clips. But for our purposes today, this will work. So that's the plan, and no plan survives contact with the enemy. So after I got out here and was setting this up to show you guys, and I started to put the milk crate together, and like I said, you just drop it down, pop the sides out, and you now have a milk crate. Now, like I said, I don't know how much this is hold, 25, 50 pounds, probably a good 50. And I started looking at this milk crate, and I started looking at this battery, and I said, well, there's a problem. That battery is not going to fit in the milk crate. Well, darn it. So I've got smaller batteries. I could use them. So I'll put something in there smaller with this inverter. And we can put the inverter in here. And this is kind of how I had it planned, I think. I don't know exactly. And this isn't going to be a build video because this whole plan just kind of fell apart. The only way this thing is really going to fit in here is like this, so you have access to the plugs and the power switch. If I put it in sideways, it would fit, as you can see, just fits. And that's not bad, and I may go with that down the road, but then of course we don't have good access to our plugs. So what I would probably do is cut out some of this lattice work so I can fasten that to the plugs. My whole plan is to wire tie this thing in here so that it's secured to the side and the bottom, and it won't be able to go anywhere. But as I said, this isn't going to work because I seriously underestimated the size of the battery and this thing, and overestimated the size of a standard milk crate. So this entire plan is scrapped. So this is where I'm going with this. And I want to share this with you regardless of our plans today. Let me get this stuff out of the way. Move that milk crate off to the side. So the inverter will run 2000 watts. How long you can run a load of 2000 watts, of course, depends on your input power. With a 100 amp hour battery, that gives us 12.8 times 100 amp hours, gives us roughly 1300 watt hours of operation. So this battery will not give me 2,000 watts to this thing. Because of the way the inverters work, I might be able to get a little more, but it probably will be less loss to heat because inverters are somewhat inefficient. Because we're going from a straight DC source to this is feeding DC and then converting it to AC. So a lot of that will be lost as heat. But my plan for this is to build this into some sort of box, obviously not a milk crate, that I can use in the event of a power outage. And with this battery and this inverter, I would be able to run a lot of appliances for a fair amount of time. Theoretically, I should be able to run a microwave off of it, theoretically. I don't know that I would try that, but it's possible. Same with something like an air fryer. That would be at the edge of the envelope, I think. I have not read service plates on all those devices, so I can't really tell you right now. But what it would do is allow me to run fans, television, some lights easily for 8-12 hours at a time. So that's kind of where I'm going. A lot of this time that this would run is based on Ohm's law. So, you know, the more things I plug in, the more voltage that I'm using, the more watt hours I am taking, which means I'm drawing amps out of this. Your average light is probably 1 or 2 amps at most, and that's with an in-can bulb. With an LED, it probably is less than 1 amp. So lights are no problem. An AC fan is probably no more than 2 to 5 amps, I would guess. Again, I haven't looked at service tags on specific appliances. I could make a giant eye chart for all that kind of stuff, but it'd be a boring thing to look at. So anyway, that's my plan. This inverter works really well. I've used it already. I'll probably make a video when I get this project finished and put together. I don't know how RF noisy this inverter is. So one thing we're going to do in this video quickly is I'm going to hook the inverter up and turn it on, and I'm going to grab the tiny SA and we're going to walk in here and see what kind of RF this thing may be throwing out when it's turned on. The other thing I want to do in this project, which I again don't have this yet, is besides changing out these cables and connectors, I want to change these to some kind of quick connect on one end or a cable with a quick connect in the middle, so I can disconnect the battery from this to go recharge the battery if I had to. I have a solar controller that will probably be wired in at some point. I have solar panel, so I could set this outside and recharge with solar during the day if I don't need it. So that's part of the end game with this. The part I had planned to do today obviously is not going to work because that milk crate is just not even close to big enough. I need one of those double-sized milk crates, probably would work. And I need to actually take some measurements before I do that. But in any case, this is about $150 on Amazon. This is about $360, I think, $380 maybe. I don't know. It's like I said, it's less than $400. And I'll put links for these things in the description below the video. But this would be a great portable power, emergency portable power solution for your shack or for your house. You've got 12 volts. You could run your rig power supply obviously directly to the battery. And if you needed AC as well, you would have AC as well. So that's the plan down the road. Today we're just going to do some quick testing and see how much RF this thing puts out. In an emergency power situation, I don't care about the RF so much. And the reason that I went with this kind of setup, if you look online, there are a number of solar generators available, and they range in price from, I don't know, a couple $300 on up to a couple $3,000 depending on capacity. So something like a Blue Eddy that's rated for 1,500 watt hours probably runs about $1,500 to $2,000. A lot more than this setup. So 150, we'll call this 350 for math purposes. I'm $500 into this total. And I've got very extended AC runtime if I need it for a lot less than $1,500. Even if this battery was 500, that puts us up to 650. And again, that's well less than half of a 1,500 or 2,000 watt hour Blue Eddy. solar generator thing. This doesn't have USB built in. Obviously you can get a USB adapter or some sort of wall wart and plug it in one of those ports and charge your phones and tablets that way if you needed to. Again, it's an emergency thing. I have a couple of smaller solar generator things here, one for me and one for my wife. So in the event of a power outage, you know, she can run her CPAP on hers overnight and I can run my CPAP on mine. So we have CPAPs covered. They would run fans, both of those that I have. I believe they're 350 watt hour rated, but it's not going to run a fan and a CPAP all night. It'd probably get you 4 to 6 hours, but I don't think it would go all night. With something like this, you can use a decent size fan and be able to run it for a while. And the reason I mention that is Alabama, hurricanes, and we have hurricanes and it's still warm here. So a fan is almost a necessity if the power goes out. In any case, let me hook this up. We'll cut over to the Tiny SA and take a look at the RF output on this thing. Stick with me. Okay, so I've got our Tiny SA out now, and this is background noise. Some of this is probably the fluorescent light. Let me turn that off a second. Yeah, some of that's the fluorescent. So we'll take that as our background baseline, and right now this is at 2 gigahertz. What we're gonna, or 2 megahertz rather, 2 meters. I'll get it in a second. And what we want to do is we're going to look down at the 0 megahertz, and we're going to stop at 30. We're going to look at the HF band. So there's our HF band noise, and that's primarily what we'd be concerned about using this kind of deal with an inverter. So there's our baseline noise, and I'm going to fire the inverter up. And we got a little bit of noise down there, and that's at it's probably hard to read on camera. That's between 7 and 10 megahertz, and it's really low. It's minus 90 dB. I don't know if this is going to focus on this very well. And we get a little more noise when we get closer up here. I guess that's picking that up off the camera. Interesting. So it's less noise down here. So setting this guy on top of the inverter, and the inverter is on right now. So that's looking great. That's certainly something I could live with, and this is going to be on the floor anyway. Right? So as we get away from the inverter, the noise doesn't really change a whole lot. And then let's turn off the inverter. So you can see we got, let me move this up in the camera and do that again. So the inverter's off, inverter on, and that's not bad. There's a little bit, and if I get closer to the inverter, yeah, see if I'm sitting on top of the inverter here. So that's looking good, and that's still low. That's at minus 80 something dB, where that little peak right there is popping up. 75 to minus 75 to minus 80 dB. So this thing is not putting out a lot of racket. That's great. Now keep in mind, you know, depending on what you're running on it, your other appliances could throw out any kind of noise, and certainly if you're running a fan or a microwave or a air fryer or something like that, it's potentially going to have a lot more noise because it's got a motor in it. But that's not terrible, and that's sitting on top of it. So if I turn it off, you see our noise goes away, and this is in the HF bands. So quickly, let's jump up to 2 meters. We'll go 144 megahertz, stop 148 megahertz, and we'll turn on our inverter. And other than a startup spike, nothing, but I think that was the fan. So I suspect that as you run this, and this thing fires up its fan because it's got a load going on it, that it's going to change that. That noise would probably creep up in the 2 meter band. So let's take a quick look at 70 centimeters, start 440 megahertz, and we'll stop at 450. That's more than the 70 centimeter band, I know. I'm just getting us in the neighborhood. And you see we got some little spikes there. But down in the noise completely. Inverter on, and it looks like it's pretty clean on 70 centimeters. So guys, that's it for today. It was supposed to be an awesome build video and project, but we did a little noise check, and this is an excellent use of a Tiny SA. If you don't have one, I recommend you get one. There's a lot of functions that this does. Is it as good as a spectrum analyzer? No, it's not even in the ballpark. But for something like this, it would let you find RF in the shack, for example. So in any case, guys, that's all I've got on this video. I appreciate you stopping by. If you would give me a thumbs up, make sure you subscribe to the channel and click that bell down yonder so you'll be notified whenever I post any new videos. Thanks, fellas. Have a good one. 73.